Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. Differential equations. In this lecture, I will discuss the solution of this question 8, especially the last part of this question. The number of birds of a certain species in a forested region is recorded over several years. At time t years, the number of birds n, where n is treated as a continuous variable, the variation in the number of birds is modeled by this equation. Given that n is 300 and t0, find an expression for n in terms of t. This is part 1. Since number 1, you have to do variable separable. So after completing the variable separable thing, we have this thing. In variable separable, I told you always bring the coefficient on left side when coefficient is in denominator. So bring this coefficient on left side with this thing. So you need to bring the entire fraction on left side. And when you'll bring this entire thing on left side, you'll get this thing. And on right side you have dt. And this is the structure of partial fraction. For this, you need to use partial fraction. Make sure you will consider 3600 with this fraction while doing partial fraction. Don't bring this 3600 outside the integral. This will make the partial fraction complicated. So we have this entire thing. So when you will split in this in partial fraction, you'll get a upon n and b upon this thing. You all know how to get the values of a and b. First, you need to substitute 1800, and I've got 1800 from this factor, and then you need to substitute 0 to get the values of a and b. This is the required partial fraction. Now, this is the integration form of the partial fraction. The integration of 2 upon n is 2 ln n. Make sure you write modulus with ln, function of ln. And this will be ln 1800 minus n modulus upon minus 1. Minus 1 is important. It is the differential of this 1800 minus n. Now get the value of c. This is the value of c. Now this is very important. You need to bring all ln's at one side. Bring this ln on left side. Use the product and quotient laws of ln and get this form. Now you need to remove ln, and you have to get the index form because you have to make n subject. So for that you need to use this index form of ln. Y is equal to e power x. This ln has base e. In fact, all ln has base e. So when you will remove this ln, this half t will become the power of e. Now you have to make this power negative, this thing. You can make this negative over here. It's better to make this term negative while bringing ln on or shifting ln on either side, like on either left side or right side. It's better to make negative here. And it's simple and it's easy to make this t negative over here. Now here, this is not negative. In order to solve the last part of this question, according to the model, how many birds will be there after a long time, you must have negative power of the exponential. I discussed this thing in detail in my lecture of differential equation, in the concepts of differential equation. So make this power negative. For that you need to take the reciprocal of this and this. So when you'll take the reciprocal of this, you'll get this thing, and the reciprocal of this is this. Now since this power has negative, therefore make this n subject. Make n subject from this equation. For that you need to multiply this 5n here, then bring this n on right hand side. Now take n common from these two terms. By taking n common from these two, we have this thing. This is the correction. In my last lecture, I wrongly wrote this thing as e minus half t plus 5. And that is why I'm making this lecture to make this correction. Now, this equation is here. Well, the last part, what happens to the value of t? Sorry, what happens to the value of n when t becomes very large? So when t becomes very large means when t tends to infinite, then this exponential will tend to 0. Therefore, this n will tend to 1800 upon 0 plus 1. Therefore, n will approaches to 1800. I hope you have understood the solution of this part well. If you want to check the solution again, or if you want to take the screenshot of the solution, you can. Well, this is all from this lecture. Inshallah, I will try to make another lecture on differential equations, of important questions of differential equations, the leftover important questions from like from 2008 or from latest years. Inshallah. Allah Hafiz.